In this video, we're going to talk about Williamson's argument against the KK principle. So before I get to the argument, I'm going to explain two important concepts for the argument. The first concept is the principle of the margin for error that Williamson talks about. So let me say what that is first. Williamson's margin for error principle says that if you know some proposition, then that proposition must be true in all close or nearby cases or similar cases. Like we did when we talked about the possible worlds theory of counterfactuals, we're not really going to unpack the notion of close or similar. We're just going to take it as intuitive. And Williamson thinks this isn't the kind of thing you could give a definition of. But we can still see the motivation for the principle, like why you might think it was plausible, by thinking through examples. So one kind of reason you might think something like the margin for error principle holds is by thinking about lottery cases. So remember, we saw time and time again that lotteries are cases where you have lots of reason to think a particular proposition is true, and yet you're not able to know it. So I have very good reason to think my ticket is going to lose, but even if that's true, if my ticket is in fact going to lose, it doesn't look like that's something I know. This fact about my inability to have knowledge here would be explained by positing a margin for error principle. Because even though my evidence makes it extremely likely that I'm going to lose, there still in some sense seems to be a nearby or a close or a similar possibility where I have exactly the same evidence, and yet I'm wrong, my ticket actually does lose. Because remember, it's a chancy process, whether my ticket is going to win or not. So it seems like the explanation for why we don't know in lottery cases, one way of putting it is that there is a nearby case in which your belief is false, in which your ticket actually does win, and that explains why you don't know that your ticket wins. But that explanation seems to rest exactly on something like the margin for error principle, because that's exactly what the margin for error principle would predict. It would say, well, since there's a nearby world in which your belief is false, i.e. a nearby world where your ticket in fact wins, you can't have knowledge. So that's one way to both see why you might like the margin for error principle and also to get a grip on what is meant by close or similar in the statement of the principle. Let me give you just one more example to think about why you might like the margin for error principle. And it comes from Gettier cases. So let's remember a very simple kind of example of a Gettier case. One example we saw a long time ago at this stage is that imagine you're in the desert, you're subject to a mirage, you seem to see that there's an oasis in the distance, but as a matter of fact, there actually is an oasis in the distance, it's just hidden behind a rock. So we want to say in that situation, you have good reason to believe that there's an oasis in the distance because maybe you don't know about mirages and you have every reason to just trust your senses. And yet, your belief doesn't seem connected to the truth in the right way. Because even though there is an oasis in the distance, that's not the cause of your mirage. Again, it looks like the margin for error principle could provide an explanation for why you don't know in this situation that there's an oasis in the distance. Because since there is no causal connection between the fact that there actually is an oasis there and your mirage, you might think, well, there are nearby cases, or it could have easily been true that you had the mirage without there being an oasis in the distance. In some sense, we want to say that could have easily happened, or there are similar possible worlds where that happened. And if that's true, again, notice that the margin for error principle says correctly that you don't know. Because since there's a world that is nearby, where your belief is false, the margin for error principle says that you don't know in this world that there's an oasis in the distance. And again, that's the right result. So just like lotteries provide both a sort of motivation for the principle and a way of getting a grip on what the principle is actually saying, so too Gettier cases give us a sense of what the principle is saying and also a reason to think it's true. So that's the margin for error principle stated in a very general way. It says that if you know something, then it must be true in all cases. And the virtue of a principle like that is that it seems to have some explanation for what's going on in both lottery cases and Gettier cases. Let's now talk about our second important concept. And the second important concept that I'm going to talk about is what I'll call inexact knowledge. The best examples of this are from thinking about perception. So Williamson gives this example of Mr. Magoo, who looks at a tree in the distance and forms certain kind of beliefs about its height. Now, if you think about looking at a tree in the distance and the information you get from that, One thing you can see is that when you look at the tree in that way, you get some knowledge about its height, in that you rule out some possible heights, but you don't get exact knowledge. If you see a tree in the distance, nobody's eyesight is good enough to just look at a tree in the distance and know exactly how tall it is. So looking is a good way to get some information. So if I look at the tree in the distance, I might know that it's not like 500 inches tall. But it won't tell me certain other things. Like, for instance, if it's actually 300 inches tall, it won't tell me that it is that height. So there'll be a range of heights that are compatible with the information I get by looking. The range is non-trivial for two reasons. So it's non-trivial because it doesn't include every height. There are some heights that are ruled out by looking. But it's also non-trivial because the range isn't just the actual height. My information is not so precise that I learn exactly the height of the tree. So there are going to be some heights that are possible for me, possible given my information, that are not the actual height of the tree. These two ideas are importantly related. The idea of the margin for error is closely related to the idea of inexact knowledge. Because you might think it's precisely the fact that the margin for error principle holds, so it explains why our knowledge is often inexact. So let's imagine that's actually true, that the tree that Mr. Magoo is looking at is 100 inches tall. Now we want to say that he can't know by looking that it's 100 inches tall. Maybe he knows some things, like he knows it's not 300 inches tall. He can rule that out by looking. But he can't narrow it down to the actual height of 100 inches. And if you think about it, again, the margin for error principle seems to explain why that would be so. Because in the relevant sense, it looks like a close case to the actual world. In the actual world, the tree is 100 inches tall. But there are other nearby cases, close cases, where, say, the tree is 101 inches tall, or 99 inches tall, where the tree is just slightly different in height from how it actually is. One way of thinking about what the margin for error principle says here is that if Mr. Magoo knew that the tree was 100 inches tall, he would have to be able to rule out these other close cases. He would have to be able to rule out that it's 101 inches tall or 99 inches tall. But of course he can't do that. That's exactly what we mean when we say that somebody's eyesight is not good enough to figure out what the height of the tree is just by looking. He cannot tell just by looking what height the tree is to the nearest inch. So there's a close relationship between the margin for error principle and inexact knowledge, precisely because if you have a margin for error principle, that would explain why our knowledge is inexact in this way. So what Williamson then goes on to do, once we have this idea of the margin for error principle and this idea of inexact knowledge, is to show that if you throw the KK principle into the mix as well, you get a serious tension. That it's hard to make sense of all three of these ideas together. Put it differently, if you want to have both KK and the margin for error principle, you have to give up the possibility of inexact knowledge. But since it looks like you can have inexact knowledge, and because Williamson thinks we should want the margin for error principle, he thinks we should reject the KK principle. So the first thing that's going to be important to do is to write down the assumptions that we're going to use in the Williamson argument. So the first thing I'm going to do is write down the margin for error principle that we're going to use. So I'll write ME, just so you remember what it is. And this is the version that we're going to assume. I'll explain in a moment why it is the way it is. But what it says is that if the tree is x plus 1 inches tall, that's what I'm going to use to write as a shorthand for the proposition that the tree is x plus 1 inches tall, then it follows that you don't know the tree is not x inches tall. So that's the version of the margin for error principle I'm going to use. So let's now think, what is the intuitive relationship between this and the margin for error principle as I talked about it a moment ago? Because it's not totally obvious when you just look at this statement, like why that has anything to do with the margin for error principle. But the way to start seeing what the connection is to first think about what does closeness mean in a case like this, in the case of inexact knowledge with Mr. Magoo looking at the tree. And it looks like closeness is just small differences in height. So suppose the tree is actually 101 inches tall. Now in some sense it looks like it could have easily been a little bit taller, and it could have easily been a little bit smaller, at least given Magoo's knowledge. So there are some close cases where it's a little taller, or maybe it's 1 inch taller than it actually is. And there are other close cases where it's a little smaller. It's 1 inch smaller than the actual height. And it seems like in the relevant sense, these are nearby cases to the actual case, given that it's actually 101 inches tall. Given all that, what is it actually possible to know about the height of the tree? So in particular, if it's 100 inches tall, we know it. Well, here's another true fact about the tree. It's not the case that it's 100 inches tall. Can you know that fact in a situation like that, according to the margin for error principle? Actually, the margin for error principle says no, you can't know that fact. Even though it's true that it's not 100 inches tall, you can't know that it's not 100 inches tall, because there's a nearby case where it is 100 inches tall. We just said a moment ago that to be close is to be within an inch of the actual height. So if the tree is 101 inches tall, there's going to be a nearby case where it's 100 inches tall, so you can't know that it's not 100 inches tall. So that is a consequence of the margin for error principle in this case. In general, if the tree is a particular height, you can't rule out, that's what the not k is saying in effect, you can't rule out that, even though you would be correct to do so, you can't knowingly rule out that it's a slightly different height. And in particular, you can't rule out that it's slightly shorter than in fact it actually is. So this is a case where it's actually 100 plus 1 inches tall, and you don't know that it's not 100 inches tall. And this is true, that you don't know it's 100 inches tall, precisely because there's this nearby case where it is 100 inches tall. And in fact, the reasoning is general, so we could do it all over again. If the tree were actually 100 inches tall, there's a nearby case where it's 99 inches tall. Here it's true that it's not 99 inches tall, but you can't know that. You can't know that it's not 99 inches tall, because there's a nearby case where it's 99 inches tall. And you could go on. So in general, if it's a particular height, which we can just represent as x plus 1, you're not able to rule out that it's slightly shorter than it actually is. That's what this principle is saying. That's what it means to write the margin for error principle in this form. And we can see that that is indeed a consequence of thinking about things in terms of the margin for error principle, because if it's this height, well then that height is a nearby case, so you can't know that this doesn't obtain because it's a nearby case. Okay, so let me erase all that. So that is why we're entitled to think about the margin for error principle in that way. But actually for the purposes of running Williamson's argument, it's actually a little bit simpler to contrapose it. So just to remind you, to say that to contrapose a conditional is just to kind of flip it around and add negation. So the contraposition, if P then Q, that's if not Q, then not P. And in fact, these are always equivalent. So since they're equivalent, we know we can rewrite the margin for error principle in this way by saying that if you do know that it's not x inches tall, then it must not be x plus 1 inches tall. So this is actually the margin for error principle we're going to use. So I'll erase the other version of it. So I've said what the margin for error principle, the version of it is we're going to use. I've contraposed it to make it slightly easier to use later on. The last thing we're going to say about the margin for error principle is that we're going to actually assume in this case that Mr. Magoo knows what his margin is. So not only is it true that he knows that it's not x inches tall, that it's not x plus 1 inches tall, but that he also knows all of that. So we're supposing he knows his own margin for error. We need to make one other sort of background assumption about knowledge, and that is that, and this is actually going to be a familiar one, it's that knowledge is closed under entailment. So I'm going to call that CL. I'm going to write it in the familiar way that if you know P, and if you know P then Q, then it follows that you know Q. So we've seen this before. We have seen that some people reject it, but we already know the reasons for thinking it's plausible. So I'm not going to spend any more time at closure. The last thing we need to say is to motivate a particular assumption about the case. So remember that we said that this is a case of inexact knowledge. The Mr. Magoo case is a case of inexact knowledge, which means that he can correctly rule out some heights of the tree, but he can't rule out all heights of the tree. So what does it mean to say you can't rule out the correct height of the tree? Well, let's for example assume that the tree is 100 inches tall. What that means is that it's 100 inches tall and he doesn't know that it's 100 inches tall. That's something that's true in our case, supposing that the tree is actually 100 inches tall. This is true because it's just an arbitrary assumption we're making about the height. This is true because it's a case of inexact knowledge. In cases of inexact knowledge, you don't get precise information. You don't know the height of the tree to the nearest inch. So let's call this H. And the very last assumption, so this says that you don't know everything. We also want to represent the fact that you do know something about the height of the tree. So for instance, if you see a tree in the distance, you're going to know it's not like 1 inch tall. That's something Mr. Magoo can tell by looking. So let's just write that down. We'll say that he does know that it's not 1 inch tall. I'll just call this L. So these are all the assumptions that we're going to use in the argument. We're going to assume that a certain margin for error holds, and that Magoo also knows it holds. We're going to assume that knowledge is closed under deduction. We're going to assume that the tree is 100 inches tall, but Magoo doesn't know that. And we're going to assume that he does know some very minimal things about the tree, in particular that it's not 1 inch tall. And what we can do is we can actually, if you add to this the KK principle, which remember says that if you know P, then you know that you know P, we can actually derive an absurdity. We can actually show that these are actually inconsistent. So to clear some space, I'm going to erase the KK here. I'll just rewrite it up here so you can remember it. That's KP, KKP. And I'm also going to move H to over here as well, which is that the tree is 100 inches tall and he doesn't know it's 100 inches tall. So the first thing I'm going to do, so let's write down again our lower end assumption. So Magoo, he at least knows the tree is not 1 inch tall. That's something even he can learn. And what we're going to show is that from the assumptions above, it's going to follow that he also knows that it's not 2 inches tall. So how is that going to work? Okay, well, so we know that it's not 1 inch tall. The first thing we do is apply KK. So we know if he knows it's not 1 inch tall, then he knows that it's not 1 inch tall. That's just what KK says. But now we want to use an instance of the margin for error principle. And the particular instance we're going to use is that, so if he knows that this holds for all values of x, then he knows that if he knows that it's not 1 inch tall, then it must just follow that it's not 1 plus 1 inches tall, which is that it's 2 inches tall. So this is just an instance of the margin for error principle where we substitute 1 in for x. So if he knows that for all x, if he knows that it's not x, he knows it's not x plus 1, then in particular he knows that if he knows it's not 1 inch tall, then it must follow that it's not 2 inches tall. But now notice that it looks like you can apply closure. So remember what closure says. If you know P, and if you know if P then Q, then it follows that you know Q. Here, the P is a proposition about Magoo's knowledge. It's that he knows the tree is not 1 inch tall. Here, the conditional if P then Q is this, and the Q is that it's not 2 inches tall. So if he knows P, i.e. that he knows it's not 1 inch tall, and if he knows if P then Q, i.e. that he knows that it's not 1 inch tall, then it's not 2 inches tall, then he knows Q, i.e. he knows that it's not 2 inches tall. So we started with the assumption that he knows it's not 1 inch tall. and we derived that it's not 2 inches tall. But notice that something disturbing starts to happen. Because we could actually just, now that we have that he knows it's not 2 inches tall, we can use the very same argument to show that he knows it's not 3 inches tall. I'll just do that very quickly. So start with the assumption we just proved, which is that he knows it's not 2 inches tall. By kk, he knows that he knows that. Now we can just substitute in 2 for x here, giving us that he knows that it's not 2 inches tall. Then it's in fact not 3 inches tall. And we apply closure one more time. So for closure, this is the p, this is the q, this is the conditional if p then q. So if he knows our p, then he knows if p then q, then he knows q, i.e. he knows that it's not 3 inches tall. But of course, there's nothing to stop us running the argument again on this premise. And then once we do that, there's nothing to stop us running it again. And in fact, what this shows is that given the other background assumptions, we can show that if he knows that it's not x inches tall, then it follows that he also knows that it's not x plus 1 inches tall. But if we can show this, that if he knows it's not x inches tall, then he also knows it's not x plus 1 inches tall, if you think about it, you can see that that is just absurd. It's actually incompatible with him knowing anything about the height of the tree, or anything above 1. Because if he knows, for instance, it's not 1 inch tall, then he can derive that it's not 2 inches tall, and that it's not 3 inches tall, and that it's not 4 inches tall. And we can keep going until we derive the conclusion that he knows it's not 100 inches tall. But remember, we assumed that that is the actual height of the tree. And he can't know that it's not 100 inches tall if it really is 100 inches tall. So what's happened is we've derived a contradiction. Our assumptions allow us to get this conclusion linking, being able to rule out that it's x inches tall with being able to rule out that it's x plus 1 inches tall. But this is just incompatible with him knowing anything about the tree at all. Because if he knows that it's not 1 inch tall, well then he would also have to know it's not 2 inches tall, and not 3 inches tall, and not 4 inches tall, and so on until he actually goes to rule out the actual height of the tree. But of course, since knowledge is factive, when you know something it's true, he can't rule out the actual height of the tree. That's an absurdity. So something has gone wrong. We've derived a contradiction because we've shown that he can rule out the actual height of the tree. That's wrong. That's not something that can hold. So we know that at least one of our assumptions has to go. We know we used the margin for error, the closure principle, the KK principle, and we showed that if that's incompatible with the tree actually being a certain height, assuming that he knows anything about the tree. We want to say that he does know some things about the tree, so one of these things is going to have to go. And Williamson's response is to say we should throw out the KK principle. This is the offender, and our response to this argument should be that KK gets thrown out. It takes a little bit of work to hold all the details in your head here of how the argument goes, but the takeaway I want you to at least know is that there is this kind of tension between the margin for error principle and the KK principle in cases of inexact knowledge. Because if we assume the two things together, if we assume both that the margin for error principle holds and that the KK principle holds, and if we also assume that knowledge is closed under known entailment and that the person knows that the margin for error principle holds, then that just rules out inexact knowledge of the height of the tree. It can't be that Mr. Magoo knows that the tree is not 1 inch tall, because then he would be able to rule out all possible heights of the tree, and that's absurd. Since it's absurd, one of those assumptions has to go, and as we saw, Williamson thinks it's the KK principle that has to go.